Simulation is another major area. Here we're thinking about a whole lot of different things that are open to us and available to us if we use this sort of simulation technology. Doing predictive maintenance is one that we've mentioned, and fixing things before they actually break down. Doing testing and doing product support by trying to work out what's actually gone wrong and when it's going to fail and what the common failure modes and things are going to be. That can be very useful for service technicians, for example. For doing training and for actually being able to train people, for example, a train driver or a ship captain, to actually train them in a virtual environment. For example, if they're going to go on to move into a new harbour or a new station or something that is new and has specific requirements and they haven't done before, they can train on that. The fighter pilots and normal pilots use these sort of things all the time and have been for years using these simulated approaches. They're very, very inexpensive. They can do it many, many times, and the cost of failure is very low compared to the cost of failure in the real sort of system. So they're very, very important in that regard. We can use it for experimentation, and with that experimentation we can optimize our systems and optimize our processes and look at what can go wrong and what could go wrong. We can use this for virtual design and actually design things in the simulation environment and see whether they'll work. And we can use this for performing updates and look at the effect that these updates will have on our end products. So they can save us significant costs, they can save us significant time, and actually produce very, very good results. With these sort of digital models, we're not putting our real systems at risk and our real equipment at risk. We're doing it in a simulated environment, which is a whole lot safer to deal with. And it's an area that we can take risks in and be confident that we won't damage something or risk people's lives. Well, system integration is something that's really important, because think about all the different things that are involved here. We've got these cyber physical systems. We've got humans combined with operational equipment, combined with IT equipment, combined with the smart factories and all this data, and that needs to communicate very rapidly, pretty much in real time. Since we've got all this equipment, it may have come from a whole bunch of different manufacturers, a milling machine from these people, this from these people, the endpoint equipment from here, the manufacturing equipment from here, the communications equipment from here, all different manufacturers, that we need some standards to be able to provide connectivity across these and integrate in this process. And so Rockwell and Cisco and others are developing some frameworks to allow us to communicate in these sort of environments and share data between these sort of environments. This is one thing that's starting really to catch up and providing that connectivity to allow things to talk together and allow our different systems to talk together and share their data, which is really important. If one thing can't understand the other thing, our smart factory won't be such a smart factory at all. This concept of interoperability becomes very, very important. Another place we see it is in cloud computing. And here we're essentially storing and accessing all our data and our programs on the internet. And so cloud computing has become something of a backbone for our Internet of Things and for big data. Where do we put our data? We put it in a cloud most generally. This is a place where it's very easy to access and very, very easy to access from a whole series of different devices. Now there's a few different ways that this can be done. Software as a service is one where essentially the software is running on some sort of a server and we access it via the internet. We see things like Dropbox, for example, and a lot of Google apps use this software as a service sort of model. Another model is our platform as a service. And essentially here we provide a platform that the software can be developed and deployed on. And our Google App Engine is an example of this, where we provide this engine, we develop our software on that particular platform and deploy that particular software. We also have infrastructure as a service. And in infrastructure as a service, we've got the servers and the storage and all the computing resources that we require. And we use these and provide this as our particular service. So, for example, Amazon Web Services, where Amazon hosts a whole lot of web services and even hosts our LMS, for example. Netflix run on this sort of model. Microsoft Azure is another example. And essentially the idea is we get all our data from our Internet of Things and our industrial Internet of Things, we store it and we process it in the cloud so that we can actually perform this processing in the cloud as well with our massive supercomputers, and we don't have to process it locally. So it's not just storage, it's processing too. Currently, the IEEE cloud computing is they're coming up with a whole series of standards for this cloud computing and cloud computation to allow us to do these things in a very organized and straightforward manner. And so there's ongoing work in this particular area. Because think about what we've got. We've got a whole lot of smart devices connecting through the internet somehow, so connecting through that communications infrastructure. And they're connecting to computational infrastructure. And particularly if that computational infrastructure is in the cloud, we've got data going across the medium and going to be computed. And then we've probably got a whole lot of feedback that's happening from that computational infrastructure going back to that equipment and controlling that equipment and making it do something. So our concept of Internet of Things that we have here, where we've got these interconnected smart devices all connecting through the internet somehow, is really the glue that holds all these cyber physical systems together. And this is a massively growing area. There's predictions that in 2017 we'll have 8.4 billion connected endpoint devices. Everything from mobile phones to our equipment that we're using, all of these different things, our sensors around homes and those smart sensors, smart equipment, massively growing area. Now, this is seeing growth of 31% from the previous year, from 2016. So it's something that's growing very rapidly. There's estimates that this will grow to over 20 billion different devices by 2020. 20 billion devices all over the world. And we're talking about massive amount of money being spent in this area. Thinking about the endpoints and the infrastructure to make them work. There's estimates of $2 trillion being spent in 2017 to actually enable this sort of technology and make these things work around the world. So massively growing area and something for the future as well. The cybersecurity is something that's very important because if we're opening up all our systems to the internet, we're at an enhanced risk of cyber attack. There's been examples of this happening. For example, in 2009, there was a piece of malware named Stuxnet. Now, this altered the speed of centrifuges in nuclear enrichment plants and caused them to spin out of control and significantly damage them. The way this was actually developed was via flash drives and spread across. People dumped flash drives in places. When they were plugged in, they caused this malware to be uploaded and damage the actual systems. So there's all sorts of espionage implications as well with foreign powers trying to attack systems and compromise systems. And so there's a whole lot of cybersecurity standards available for us, like IEC 62443. These sort of standards, in concert with the sort of work that's being done by companies like Symantec, are really trying to work on end-to-end cyber solutions that will make this Industry 4.0 not only functional, but also safe as well. Now, depending on who you talk to, there's a number of different definitions of Industry 4.0 and Industrial Internet of Things. Some have more, some have less things associated with them. And so this one comes out of PricewaterhouseCoopers, PwC, who have been doing a whole lot of analysis in this space. And they've added things like authentication and fraud detection in there, location-based services, who has a mobile phone that doesn't have GPS based in it these days. Advanced human-machine interfaces and wearable technologies, all of these sort of technologies as well. But we see at the heart of it, we have these concepts of data analytics and actually using that data and processing that data to get meaningful results out of it. We're seeing massive adoption or expected adoption happening across a whole series of different industries. And we see some of the industries that are most to gain. People are looking at electronics industries and aerospace and manufacturing industries as well. But there's even some predicted ones, for example, in food industries, that we're seeing people saying, well, in the next 5 years, there's huge gains that could be delivered in these sort of areas. One place that I've even seen it in food industries is going through the drive-thru at McDonald's. These days, a lot of McDonald's, you'll see a little robot that will actually remove the cups and actually fill the cups up based on the orders that you've produced. So you go to one window, you say, I want this, and it'll actually fill the cup up to the right size with the right amount of fluid in there based on what you've actually ordered. And that will help the person and assist them, reduce the amount of spillage and things like that when it's working, to actually serve your order and serve it faster. So this is something that's growing, and although it might have fairly low adoption at the moment, over time it's predicted to grow very, very rapidly. And interviewing people and looking at the sort of benefits, people have looked at, they've said, well, why do we actually do this? And one of the main reasons has come about is the reduced costs involved. with those reduced costs, we can actually improve the company balance, we can put more money into R&D, better value to shareholders, and we can look at actually having a lower cost to market and giving us a competitive advantage over our competitors. We're looking at increasing uptime and availability of our systems and actually increasing our speed. It's a significant competitive advantage if you can provide something faster and more cheaply than what your competitors can. There's quality and safety also involved there, which are significant advantages of this Industry 4.0 sort of approach. And we see this isn't just a German thing or an American thing, it's being rolled out all over the world. And there's significant initiatives in Japan, in China, in the US, in Germany, but in many countries across Europe as well, to how can we improve things and what initiatives can we have in our own climate to have Industry 4.0. In Australia, we even see it happening, and big companies like Sudden Tools, for example, have been market leaders in integrating Industry 4.0 into their tooling processes and into their manufacturing processes. These have been recognised around the world.